So here we are, quadratic word problems, okay? When sketching the graph of a quadratic within a context, right, within a word problem, you must label the axes, okay? Must label the axes with words and units. So, example, you can't just put time down, you have to put down time. Is it in minutes, seconds, hours, days? What is it? Okay? So units have to accompany your label if you want full marks. Start just like before. We find the vertex, right? And all intercepts, just like when that's a possibility, we want them all, okay? And they'll give you a good idea of what scale to use, right, to determine the scale that you're asked to graph, okay? And most of the time, variables need to be positive. So the majority of graphs are limited to quadrant 1. Notice that I'm not saying all. I'm saying the majority, okay? And so here you have a quadratic. You should recognize that this is a quadratic because it's got the t to the power of 2, right? But you notice that the letters are different. It's no longer y and x, okay? And that's okay. So when you're given an equation, I always have to tell you what the letters represent. So h of t represents the height in feet, and t represents the time in seconds, okay? So one thing I need you to realize is that the t represents our x, okay? So normally you have x and y, correct? But within this context, every single point is going to be time and height, okay? Because remember, let's go back here. Let's go back to this one and just write at the top. We could write this 4.9 x squared, let's do plus 17x plus 2. Okay? We could write this in terms of y and x, right? So just remember, x is always on the right-hand side, y is on the left-hand side. We're not going to trick you that way. It's always going to be the case. So you just have to make sure you understand we've got time and height. Because time is here, that's your x. Height is over here, that's your y. Okay? Every single point on this parabola would represent the time and the height at that point. Okay? So immediately you would have to label this as time and seconds, page 32. And this would be height in what? We were told feet. It could be yards, meters, inches, right? Centimeters. You got to be careful. You got to read. So that would be the labeling part of the graph. And notice that we're in quadrant 1 because time cannot be negative. Time cannot be negative. So you know how normally your calculator will show you this, and we used to find this x-intercept here? Look up on the screen, not at me right now. Remember this x-intercept here? We no longer use it because it's not applicable. We cannot use it because time is negative at that point. We start when time is 0. When the action, like let's say you throw a ball at time 0, you throw it, and then that's when we start counting. So in this scenario, we only focus on positive time, and in this case, height can only be positive as well. Okay, it either hits the ground, right, bounces up, but it will not go underground, okay, in this context, right? So we have height, we've got time, and so every single point here, this one used to be called we still call it the y-intercept, okay? But we will now also refer to it as the initial height, okay? If the question says, hey, what's the height at the very beginning, what's the initial height, they're asking for the y-intercept, okay? So basically, this will always be 0 followed by a number. And by the way, if it's in general form, it's actually 0C as well. It's all going to be, C is going to be some sort of value, which can also be 0, by the way, but not necessarily. Then we've got this point here. We used to call that the vertex. We still will refer to that as the vertex. But this is the maximum height, right? So I'll just say max height in this case. Vertex will give you the max height. So it's actually, if you think of time and height, this value, the y value, will give you the maximum height achieved by this projectile, okay? And this is the time, right? This value here will tell you how long it took for this projectile to reach the maximum height, okay? So obviously there are coordinates all along the way, but this one is special to us. Then the ball falls, reaches the maximum height, and then gets to the point here. This is called the x-intercept. Okay, it's called the x-intercept, and you know that already. What does it tell us? It tells us, I will continue here, time the object remains, make sure I write this down, airborne. Okay. Time the object remains airborne or remains in the air. It hits the ground, right? Hits the ground at that point. Okay, so they're special. An x-intercept will always be a number followed by a 0. Okay, so you'll have to figure out the value, but we know that the y value will be 0 at that point. I think no surprises there. Okay. So, context here. Let's keep going. So, domain and range. So make sure, I'm going to use my two colors that I use for domain and range. I use pink for domain in this case and green for range. Okay, it doesn't really matter, whatever two colors. So there's a domain and there's the range when you have a word problem. So things are going to change here. And here you go. I'm going to write this down. Most questions, most scenarios have no infinity symbol. Okay? A bunch of exclamation marks there. I will highlight that as well because students love their infinity symbols. Because I told you at the beginning, okay? So most scenarios have no infinity symbol. I can honestly not think in this course, next year you will have more infinity in grade 12, but in this course, not very often. The only time you have infinity is if there's no word problem associated with that question, all right? So here we go. For the domain, if it's set notation, you will use this most of the time. It will go from 0. So for example, time in this case starts at 0 and then stops here. Okay? So you have to use the letter that the equation gives you. So in this case, it's t. And then you'll just go, it has to be less than or equal to greatest x. The greatest x value that you can possibly find there. I used to put x-intercept there, but I no longer do that because students thought it would always be the x-intercept. But sometimes the ball will not land on the ground, or the person will not land on the ground. The person might land on a trampoline, or the person might land, or the object might land on some sort of box that is like above ground. So I'm not going to say x-intercept here anymore. It's just the greatest x value in this story. Okay? Interval notation. You usually go from 0 to greatest x value present. And notice that there are square brackets on both ends. So both of them are going to be numbers that are included in our domain. Can I just, maybe I should repeat these, the x values. Okay, domain refers to the x values. Range refers to the y values. Some students mix that up. So you got to make sure you know that it's different. For range, you're going to have to grab the lowest y, value in this scenario. And then you're going to, in this case, the letter y is replaced with h, because h represents our y variable in this case. And then that will be less than or equal to greatest y. Let me see if I can zoom into that a bit more. There we go. So lowest y, greatest y. So h is somewhere in between that, but it can also be including that. For range, is simply lowest y, comma, greatest y. Remember, domain, I'm using pink today, and range, I'm using green. I would honestly say, have this on your study sheet. This is domain and range. But just make sure you say domain and range with a word problem. So have the scenarios where there isn't a word problem, and then have this one on there when there is a word problem. Okay? Fun stuff, eh? I know. I think once you practice this, which you will see on the back side, hopefully you'll be able to wrap your head around it. Okay, let's go to 33. Whoa, okay. What's happening here? Okay, so if I asked you, state the domain and range, you can always pick which format you like. If you like set notation more, go with set notation. Interval, it doesn't matter. I will never force you. However, I may give you a domain and range in either format, and you have to be able to read it and know what's you're being told. Okay, so let's try this one here. Let's figure out our domain and our range. And I'm going to tell you, I'm going to go set notation first and then interval. I'm going to give you both. Okay, you decide which one you prefer. But my domain was pink, correct? That's the color I picked. So my domain is my x value. So I look at the graph. The graph starts right here. I travel, listen to this part. I travel along the x-axis and I keep looking. Do I see a graph? Yep, I see a graph. And then it stops here, right? Stops right there. There's no more graph. I can't continue. So the domain is kind of saying you can travel along the x-axis this way from here to here and still see a graph. Okay, so for set notation, we use the squiggly brackets. So we're going to go from 0, and notice that it's length along the x-axis. So most likely, the letter used in this scenario would have been L. Like if I had given you an equation, it would have probably been L because it's length here. Okay? And that would be less than or equal to, what's the greatest x value that you can see on this particular sketch? And you should be able to say 450. Okay, so L goes from 0 to 450. That's it. After that, there's no more graph. So that's your domain. Let's do the interval right away. I love interval. So much easier. You don't have to put any letters in there. You don't have to worry about that. You just go 0 to 450, done. Okay. Now my range, same thing. You travel along the y-axis for as long as you can see a graph. So I can still see a graph. I'm kind of looking out this way. You can look both sides. There's no graph on the left, but there is one on the right. So you keep going until there's a graph, until it stops, right? So I will make a dashed line saying I know that it stops at the vertex, and specifically the y value of the vertex. I'm going to highlight this one green as well. So for the range, I'm going from 0. Maybe I'll add this to your notes. It's implied that this is 0, right? And it's implied that at the top here, it's 50,000. Okay? Same here along the x-axis. It's implied that it's 0, and we know that this is 450 along the x-axis. So maybe add that to your notes. 450 here, and then 0 to 50,000 there. So I'll simply use A for area, and then make sure 50,000, that's the greatest value for y. Okay? And then here, it would simply be 0 to 50,000. Like that. All right. This is what I'm going to ask you to do. The rest of these questions, and I'm not going to post the answer key because I want to go over it with you, but the rest of these questions on 33 and 34, I'm going to ask you to do. I shouldn't put homework right here because it's going to block here. So just right at the top of this, homework, page 33 to 34. I know it's not, you might not get it right. I honestly don't care. Just give it a try. Give it an honest try. And trying doesn't mean looking at it, it's like, I don't get it. Like, I'm not doing this, right? Walking away. No, you gotta try your best, right? Based on what I just did. And they go all over the place. So I want to see how you do. I'm not going to do them today. Domain and range, you should have seen that last year. I know you probably have good memories about domain and range, right? Notice that none of these, listen carefully, none of these have an arrowhead on them. You see that? None of these curves have arrowheads on them, meaning infinity is not an option here. It stops. It stops on both ends, okay? So you got to watch out for that. Okay, let's keep going. I'm going to skip this, and I'm going to go straight to 36. We're going to do a word problem together. Okay? And I'm going to come back to 34, 35 tomorrow. I promise you that. The path of a baseball that has been hit can be modeled by the following equation. There it is. Where h of t is the height in feet, and t is the time in seconds. Okay? Just remember, this is your x value. H is your y values. You know that because the y is always on the left side, and the x is always on the right side. So right now, I want you to write this down, that every single point is going to be time and height. Every single point you find is going to correspond to the time it takes for this projectile to get to a certain height. That's just bottom line here. All right? And so we're asked, what is the initial height of the trajectory of the ball? In other words, i.e., at what height was the ball hit, right? So we're going to go ahead and do that here. We're going to go to A. And we're going to say that this happens at the initial height, right? This can be found at the y-intercept, or initial height. The y-intercept in this case is 0 what? It's in general form, right? So we can just grab that 4, 0, 4. That's the y-intercept. Therefore, the initial height is 4 feet. Okay, so this 4 here at the y-intercept told us that this is 4 feet. Okay. That's it. B. Determine the maximum height of the ball. Where would you find the maximum height of the ball? What do we call that point? The vertex, right? Let's go find it. That one we cannot do based on that equation just like that, just by looking at it. So let's grab our calculators. I'm going to clear whatever is in there. Got to be careful. It's a negative, right? So we know this is pointing down, correct? We know this is pointing down. So negative 4.9 x squared plus 35x plus 4. I'm going to let y2 equal to 0. I'm just going to leave that there. And let's just hit graph. Not a good graph, in my opinion. Okay. So I'm going to try zoom standard. I'm going to reset my window to a 10 by 10. So I'm going zoom standard. And it's zoomed in a bit more, but I still need to make sure my cap here is included. So I'm going to increase my Y max here. So I'm going to go to my window, and I don't know, I'm going to go 50 for Y max here. Just change your Y max to 50, hit graph, still not good enough. So what should we do, 75? That's pretty good. So my Y max, I just changed my Y max to 75. Okay, and then we're good. This is a pretty good graph. You might argue, I don't need to see this part. It doesn't matter. Let's go find our vertex. Second trace, this is a max, right? So you pick a point to the left, pick a point to the right, and there it is. I'm just going to say max height is found at the vertex. Okay, so I'm going to say second trace max, right? My vertex is, I just lost it, I have to redo it. So if you press any button, it will lose it, so you have to do it again, okay? So by mistake, I pressed a button there. So this is 3, oh boy, okay. 10:20, I lost my